Hello, everyone, and welcome to our tutorial session this evening. Today we'll be looking at an introduction to large language models. Okay, yes, I'm just looking at the slides here and some exploration with ChatGPT API. Promises to be a very exciting and educative session. So I hope we're already well excited, eager to learn. Um, I know there was some issue with the timing set on the meeting schedule earlier. So I don't know if that's why we don't have a lot of people joining. But luckily the session is recorded and will be available. And just not to waste too much time. I know we've all had a long day. And we'll just get right into it. We have Assistant Professor Ajumand Yunus, who is an assistant professor at UCD School of Information and Communication Studies. She teaches and researches in the area of artificial intelligence, society, and digital policy. And she would be taking us through this session today. So I'll just hand it over to you, Ajumand, if you're ready,
Yeah,
so we can get started. Yeah.
thank you for the introduction. Sorry, I have a bit of a cold, so please bear with me. But hopefully,
Okay.
we'll get through it. So, yeah, he already introduced me that I'm an assistant professor in UCD's. We call it iSchool or ICS, School of ICS, Information and Communication Studies. So today I'm going to talk about large language models, and we'll look into some code with the ChatGPT API. Now, we know that generative AI and LLMs have become the new talk of the town, and everyone is about, oh, I use ChatGPT for my homework, I'm using it to write emails. Everyone has used it in some form or another. Uh, the thing is, the best thing about it is the content it produces. It's very hard to find out if it's written by a human, or eventually some people do detect, but you can never be sure. And as lecturers, it's something we, you know, talk about very carefully because we don't want to be accusing our students if they haven't used it. So it's causing a huge stir, not just in the computer science and AI community, but also in other communities. Because let's face it, it can write excellent essays, and giving students homework and marking and everything has become a huge dilemma for all of us. Now, the chief idea is that massive computational architectures like GPUs and huge sets of training data from the web have enabled this technology. So what happens is that I'll just go a little bit into what's happening under the hood. So, for example, if you ask this question to, let's say, a human or even a child, a 5-year-old or a 6-year-old, the color of the sky is, he or she will instantly blurt out the answer blue, because we have been seeing the sky for ages and everyone knows that it's blue. Of course, the language model will too. However, let's say we ask this question. The Trevi fountain is in the center of Rome. A child or even some adults might not know the answer to this question, but ChatGPT or LLM will instantly complete the answer and say Rome. How did this happen? How was ChatGPT able to do this? Is through a process known as text generation. In text generation, basically you give it a prompt, and with that prompt, so this Trevi fountain is in the center of was a prompt, and it completed it with the answer Rome. Similarly, if you have prompts like I love eating, it can fill many options. Now, it would also depend on the data on which it was trained. What do I mean by that? We'll see in a bit. So we have I love eating bagels with cream cheese, or my mother's meatloaf, I love eating out with friends. These type of completions can be expected. How it works, the fundamental idea is the same. Like in all of machine learning, we know there are two paradigms: supervised learning and unsupervised learning. Those familiar with machine learning and those who've been working on machine learning for quite some time know that these are the two main things that help train models, and supervised learning is still the more predominant one. So let's say, for example, we are doing a class of task of restaurant review sentiment classification. Our input would be some sentences, and the output would be labels positive or negative. So the pastrami sandwich was great is a positive uh, review. Service was slow and the food was so negative. Now, we know that how it would work is if we have another new sentence, it's going to classify as either positive. And we have many examples of these kind of sentences. And that's how our traditional text mining used to work. We used to pass these sentences. It learned patterns based on the input and output pairs, which is called training data, which is also called label data. So it used to get labeled data and then train the AI model, and then we deploy and call the model. So even with LLMs, this fundamental idea remains the same. How, you would ask? Well, uh, for that, I'm going to skip some slides and move forward. I'll come back to this. So what happens is that in LLMs, it's using supervised learning to predict basically the next word. That is why in some of the literature, in some of the uh, books, or in some of the tutorials, or some of the researchers, you'll see that LLM terminology is replaced by something called next word prediction or next token prediction. How? So basically what's happening is each time our input is, let's say, my favorite food is the supervised learning task here is to predict what it will be the next word in here. Bagel. Now we have bagel. We append it, my favorite food as a bagel with. Now we have another. So the sequence goes on and on and on and on until you have a whole essay or a whole text. So in principle, at the very root of it, it is still a supervised learning task with nothing happening but just next word prediction, right? So it's still that same old machine learning that we used to do. It's not new technology. It's not something that came out of the blue. And the fun fact, not many people know that the paper on which the whole idea of LLMs is based was the transformer paper and transformer model. Those who have been in the field of natural language processing for quite some time know that this model has existed since 2017, and it was basically a paper by a researcher in Google and in Canada, I think in University of Vancouver. These two guys wrote the paper, and unfortunately, the person who did work in Google behind the transformer model, he was laid off, I think a year and a half ago, which is very unfortunate reality of the corporate sector. Anyways, so the title of the paper is Attention is All You Need. And in the research community, in the NLP community, there are a lot of jokes around it. So the NLP community, my kids at 5 a.m., attention is all you need. This is a very important paper if you want to understand the technology behind it. And it's a highly, technical paper, but I'll try to go through some of the ideas behind it and what's basically happening. How is this remarkable technology working to predict next tokens, and how are all these next tokens getting combined to produce such lovely, awesome texts as if they are being written by humans? So before transformers, we had something called RNNs, recurrent neural networks. They're still in use today for some tasks because they're more efficient than transformers. They don't require huge, tons and tons of GPUs. So they're at that time, the memory and computer was not that much. So that's why what we did is we just paid attention to the word before and word after. So it could not do tasks such as the milk is bad, my tea tastes. It could not have predicted, but the transformer model can. The most it can predict is the milk is up to here, up to in one sentence. Whereas the transformer model can do huge chunks as well, or whole essays or huge sentences. Now, why did they come up with this? What made them? So, in natural language, in human language, there is a challenge. We have lots and lots of forms. Like, for example, look at this sentence. I took my money to the bank. Now, which bank are we talking about? Are we talking about the river bank? Are we talking about the banks which have money, like, let's say, Bank of Ireland or AIB? Or now, another sentence, the teacher taught the student with the book. Which book? Teacher's book, student's book, or both? So there seems to be a lot of context missing here. Now, researchers thought that if there is some way to model long context, we can do a lot of generative text generation tasks and make the computer produce even code, which is happening, make the computer produce essays, emails, a lot of stuff. And this is the chief idea in that paper. Uh, what's enabling all of this beautifully is this architecture. I'll go into a bit of the detail of this architecture, but RNN would be sequential, right? So one word after another, and the neural network that is behind it can process in a feed forward or just backward fashion. Here, however, you have something called attention networks, and you have multi-head attentions. So simultaneously, you can process chunks and chunks of text in parallel. And this also enables to feed large amounts of text data to the model, not just, a few 1,000 examples or million examples, but even the whole world's data. And in fact, it has become a very huge controversy within the AI ethics paradigm that ChatGPT, when its first version came out, it trained itself on tweets, it trained itself on all the data of the world. And people were like, This is my data. How can these people use it? How can this company use it?" And now there are guardrails against it. But this is still an ongoing policy issue, and EU Commission, US government, everyone is getting involved in it because it's so powerful. The architecture and the computers are so powerful that it's able to process huge and huge chunks of data. And that's where its power comes from. The computational power, one thing, and the huge amounts of training data, like all the web. Imagine all the text it produces in the world being input, and that's why it's becoming so powerful. It knows a lot more than us, like I showed the Trevi fountain example. Now, coming back to our example, the teacher taught the student with the book. With RNN, it would be this simple model. With transformer models, it's going to go into long ranges, and the would process this sentence, book, the with every other sentence, every other word is being processed with every other word to learn various relationships, like say entity relationships, like say relationships between nouns and verbs, huge contextualizations. And this is just one example of one sentence. Of course, the text that we pass in is composed of many, many, many other sentences, right? And what is this yellow thing called? This is the self-attention thing, where words are paying, learning from each other, trying to learn contextualization with each other. And that's where the power of transformer models comes from. This yellow thing is called self-attention, and they're passing on weights to each other to find out which word would be more important, and based on that, do the next prediction task. So basically, you have an encoder and a decoder. So this part of the transformer is encoder, and this part is a decoder. Now, yeah, this is an abstraction. Within it, there are multi-head attention, feed forward, and then furthermore multi-head attentions and feed forwards and everything. So what's happening? You pass on input and you get the output. Output can be a classification. Like, for example, if you say you want to do the restaurant review classification example with a transformer, you just feed in all the reviews and the output would be positive, negative. Still, those tasks that were traditionally performed using RNNs or simple machine learning algorithms can be performed with this, but now you pass it through encoders first and then a decoder. Now, what's happening is there is first an embedding layer. In the encoder, you pass the input in the form of text, and it gets encoded into a representation of numbers, vectors, right? And then the output that comes from the encoder, this goes to the decoder. So the numbers, the vectors come in here, and then the output again could be text. It could be one classified example, depending if you have a softmax layer or any classification layer here, or it could be like the machine translation or even text generation. It could be strings of text. So that's the basic idea behind transformer models. So let's say the teacher taught now what is this? This is a process called tokenization. And I'm going to show you through an example of how tokenization, how various forms of tokenization can affect how what ChatGPT can or cannot do, right? So let's say because at its core, it's still machine learning, and machine learning does not understand words. It only understands numbers. So that's why the tokens have to be mapped to some form of numbers. Let's say this is the entire vocabulary where the is mapped to 342, teacher age 79 taught 432, and the again 342 because that was the token ID corresponding to the word the in our tokenized space. Then we model it in an embedding, and this is the old word2vec model that existed, which I did not cover because then that would be a lot. But I'm thinking because we have a technical audience, they would know or they can read up on it. So basically, every number has a vector representation, and that vector representation maps its context within a space. So let's say, for example, yeah, student and book would be closed in the space, computer internet would be closed in this space. Let's say we have only a three-dimensional space, fire would be here, fox would be near some other animal. So meaning is already captured through this embedding layer. So we have this layer, and then we have another layer called positional embeddings also. So we preserve not just the contextual meaning of each token, but also their position here. Uh, like where in the text are they? Uh, so it's a very rich structure that's being passed to our encoder, and it's going to map it to finally another number, which is through self-attention, and then another self-attention layer within the decoder, and then finally use that to classify or whatever task you have to perform. So this is the essential idea behind transformers. Learning context of words, learning relationship between words, and using all of the different inputs or training data to understand how words work in unison with each other, and then producing text. So finally, what the output is this. This is for one word, right? Next word, one task. So these are probabilities. Now let's say I love eating cream cheese bagel. Now the probability of cream, or let's say another word, milk, how, whatever, is each word assigned a probability in this space, and the word with the highest probability is picked. So all of this is going on very quickly behind the hoods, and that's how the LLM is working. So now, and then there are different architectures. Sometimes you have encoder only models, you also have encoder decoder and decoder only models for various optimizations. As I mentioned, so encoder is going to input your prompts, basically the text, like I showed you the prompts here. This one, my favorite food is a. So this is going to be a prompt, and with the contextual understanding, like you saw the word2vec embeddings and the positional embeddings. So it encodes all of that and produces one vector for one. It it's going to produce one vector for my, one vector for favorite, one vector for food. Sorry. Yeah, and then this is all these vectors are passed on to the decoder, which accepts the tokens and further generates more tokens. Now, keep in mind, the output from here is vectors, is numbers. The input that goes is text. The output from the encoder is numbers. Again, here the numbers are passed to the decoder, and the final output is also text. So if you have an encoder only model, how is that going to work? It's going to only output vectors of numbers for you. Now, how are they any useful? They are if you apply a final, let's say, classification layer like a softmax layer or a sigmoid layer or something like that for classification tasks. BERT itself is an encoder only model. Encoder decoder models, they are mostly used in, you can imagine, machine translation. Like T5 model, there is a model called BART. These are all used in when you want to translate from, let's say, English to French. You want to give the input in English and you want the output in French, or you want input in French and the output in, let's say, Indonesian language or things like that. That's where you use encoder, decoder. So basically, your English tokens will be passed to the encoder. They will be converted to vectors. Those vectors are passed again to the decoder where they learn in the output language. And let's say French, and here you get the output again in French. Decoder only models would be where you just pass the numbers. Uh, of course, these are converted internally somewhere. You either pass their embeddings or you either get them from here or you already have them stored in memory somewhere by learning from another pre-trained data. The GPT models, Llama, or and even ChatGPT and all are decoder only models. Um, so this one I already covered. So how LLMs are a supervised learning task. Nothing fancy. It's nothing rocket science. Nothing. Not a new technology. The only thing that's new here is next word, but all happening so fast and in so much parallelization that it seems to you that something new is being produced, whereas it's just stitching together words and words and words, the next words that keep on being produced. I hope this is not too difficult of a concept to understand. The first time anyone hears this in any of my language processing classes, they're fascinated. Like, because I give them an introduction to machine learning and then supervised learning and simple examples we run through. And when they're taught that LLMs are nothing but these supervised learning models stitched together, they're like, oh, wow, why didn't we think of it? It's just how it was abstracted and sold to you that you thought it's something very marvelous, whereas it's not. So I'll take a small break, or maybe we can take the questions at the end. Yeah, we'll take it at the end. It's fine. Now, another thing is there are two types of LLMs. Like the one I mentioned and the one that ChatGPT uses, there is a slight difference in practice. So basically, the base LLM that every model is using is the text word prediction task, and it's based on the text training data. So, for example, we have once upon a time there was a unicorn, and we wanted to complete, let's say, complete this story, or based on what you learned from what training data was used to train you. Can you tell me this sentence, what will come after? So they're gonna say, once upon a time there was a unicorn that lived in a magical forest with all her unicorn friends. Now, if we pass it a question, let's say, what is the capital of France? The base LLM might not say the answer, the correct answer. Paris is the capital. That's what we expect, right? That's what we want it to say. And ChatGPT would tell us this answer. But the base LLM might say, what is, it's just going to rephrase this. What is France's largest city? What is France's population? What is the currency of France? Why is this happening? Because this was the base LLM, and it didn't know that you're looking for a question-based approach and you want an answer. Those are called instruction tuned, and you have to somewhat tune them to get it in this form. How do you do that? Is a different process, and it uses something called uh, yeah, it uses something called fine tuning, which is not rocket science, which is fairly easy, but basically it's done through the process of RLHF, reinforcement learning with human feedback. And that's where the novelty by the company OpenAI came in. But it's not a huge thing. Any company can do it, and a lot of companies are now doing it. And that's how so many, everyone, the base LLMs are open source, like GPT-5, oh, sorry, GPT-3, and they're still open source, and you can use any of those. So those are trained on the huge and huge amounts of text. And then you then uh, basically rate the answers and use reinforcement learning and apply human feedback to improve the process. Now, this is also the methodology behind ChatGPT improving with time. So, for example, let's say you have a window, you ask ChatGPT to write an essay on a topic for the first time. The first iteration is always crap. When you prompt it further and further and you tweak it, you do a conversation with it, that's where the output improves. And that's why prompt engineering in itself is a whole area where people might think that AI is going to replace our jobs, but if you're good at using AI, if you're good at prompt engineering, AI might be very useful and may complement your behavior and may complement you in your job, because the reinforcement learning that relies on human feedback is still a very important part of LLMs. And to improve the output. You may have seen this yourself, that the first, if you ask it, okay, this is an email I got from my supervisor, please reply, the first iteration will be very crappy. But if you go on and engage in a conversation with ChatGPT, it's going to make it better and better. I'm pretty sure you may have all seen this. Now, let's go to the code, and I'll come back here because I want to show you guys something, as this is also a demo. Can you see my screen, the code, the notebook? Just one person
Yeah,
can.
we can see it.
Okay, perfect. So, yeah, this is not it. Where is it? Yeah, here. So for the first time, you will have to install OpenAI. This is how you do it. And this is a Jupyter notebook. I'm pretty sure you all know how to set that up. I'm not going to go through that. And then also TikTok in. So what is this? Um, Basically, when you have environment variables, which I have set in my Windows, my OpenAI key, I cannot show you that because I have a paid version and I'm. So how the model behind the ChatGPT API is something called pay as you go. And depending on your token usage, I think they charge $1 per 1,000 token or something. I don't know what the current rate is, but you will have to be very careful with how many tokens you pass. And you have to have credits beforehand. That's how it works. And based on how many tokens you process, it's going to cut that amount. And once you're run out of, let's say, money in your account, you have to load more, and otherwise it's going to stop working. So that's how the API works. So I have a ChatGPT API account on OpenAI, and I used my OpenAPI key in my environment variables, and this is how I'm going to load it. So this part of the code does that. Now, some people, some developers, still what they do, they would have this string OpenAI AI API key, and they would put it somewhere here. This is not a safe approach because then your key will be out in the public, and it can be stolen by somebody, and OpenAI is going to charge you because it's your key. So always a good idea is to set it in an environment variable. If someone wants more detail on that, you can email me, but it's not a complex process. In Linux system, it would be a bit different than Windows, but overall the idea is the same. So let's run this part. I've already installed uh, the OpenAI API, so it should say requirement fulfilled. Yeah. And now the key is here, client OpenAI. And then this is the part where the magic is happening. This function, this keeps on changing with every new release of OpenAI. So you have to look in the documentation. My code that I was working on earlier was the 0.28. Now they've moved to version 1 something. So I had to upgrade it a little, the code. But basically what's happening is that you pass it a prompt, and the model, here you tell it, I'm using turbo instruct. Turbo instruct is the instruct model. So let's say first we run this, and then what is the capital of France is going to give us our answer, right? Let's ask it, what is the capital of Ireland? Dublin, right? I just wanted to demo it for you. So this one is very easy. Now let's do another simple thing to show you the tokenization magic. Take the letters in lollipop and reverse them. Is this the answer? Now we know that even a 5-year-old can easily do this kind of task, taking the letters in lollipop and reversing it. POPI, but it started with PIL. Why did that happen? Let's move back to the slides, and I'm going to answer this question for you guys. Okay, so you remember I mentioned something called tokens here in this slide, right? Yeah, this slide. And I told you that machine learning algorithms or even the transformer model or LLMs don't understand what words are. They have to be mapped to IDs. Now, there are different methods of tokenization. Here, let's say this is a sentence, learning new things is fun. Now, all these words are pretty well known, so it's going to tokenize like this, learning new, this is fine. But prompting is still a new word in the dictionary. And the tokenizers that exist out there are not much familiar with the word prompting. So they know prom, the dance prom, or they know PT. So they're going to tokenize it like this prom based on the tokenizers that are already existing in the literature, right? So they have PROM, PT, ING. So this is how it's going to be. The different colors you see, this is how the tokenizer is tokenizing, and that's why some discrepancy happens. Now with lollipop, what happens is L is treated as one word, all is another, and puppy is another. That's why it did that kind of output because of the tokenizer. And that happens a lot when you work with new languages, and there are a lot of challenges when ChatGPT deals with new languages. One way to solve this would be very simple, nice way. Um, where was I? No, not this one. Sorry, I have 2 or 3 notebooks. I'll share the notebooks also with you guys so you can send it out with the code or YouTube video or whatever. I don't know how it works with Women in AI, but I usually upload in a zip file and then you can spread it. Or I can upload to my GitHub. Now let's try. See? POP. What we did is we inserted a hyphen in between and it worked. So these are some clever tricks that you have to do, and it helps you understand the importance of tokenization when you're working with models like this. So now, usually with the English language, tokens are usually 4 characters. It could be, but this is the average. And the different models that are used inside ChatGPT, GPT-5 Turbo, DaVinci, and there are several. You can look into the documentation. So they usually have limits on the number of tokens inside the input and the output. So if you give more than 4,000 tokens, it's going to throw you an error. You can try out using long documents, but I think the latest version 4.0 has a much larger limit. Now, one final note, recall the restaurant sentiment review classification. I know a lot of us have spent entire PhDs on doing sentiment analysis before the advent of ChatGPT. But with models like ChatGPT, it's very easy to develop an app that can easily do sentiment analysis, say for us. Earlier, what used to happen, we would have spent months. This 1 month is still less. Some people, some PhD students, or some people used to spend months and months collecting label data for these kind of tasks, and then we would train our models on the different on the data and different models, not just one model, and then finally deploy and test those models. So a app that could take year to develop with the traditional supervised learning methods, now with prompt-based AI, you just specify different types of prompts within your application development, and then you can call the model in minutes and hours. I am going to show you another example of what I'm talking about here, how app development can work with ChatGPT API. So this is something called AI Assistant for Journalists. Okay, I wrote a prompt here, and I wrote another ChatGPT function. Here, I'm using, in the first example, I used GPT-5 Turbo Instruct. Here I'm using the GPT-4 Mini, the new one. And I'm also assigning something called roles within the prompt. So prompt role, you are an assistant for journalists. Your task is to write articles based on the facts that are given to you. You should respect the instructions, the tone, the length, and the style. Now, how do we pass it? Something like this: content prompt. Now, the prompt itself, you can have prompt role, facts, and the facts would be encoded in something like this, a list that is passed. The sky is blue, the grass is green. This is our list of facts. We're going to pass it here, okay? And it's going to join this list in the form of a string here with prompt role. And you can also pass a tone. Here I'm passing the tone sarcasm and also the word style. There are different styles. You can say blog post, you can say article. I used just tweet here. Now let's see what it's gonna output first. Wow, groundbreaking news. Did you know that the sky is blue? Shocking, right? So it based on my tone, it modified. Let's make it funny now. Ever notice how the sky is blue and the grass is green? Nature really nailed the color palette. It's like Mother Nature was feeling a bit artsy and decided to paint the world. Meanwhile, I'm here wearing khaki and wondering if I should have consulted her about my wardrobe. Maybe I'll just lie on the grass and stare up at the blue sky. That's some serious color coordination, folks. Let's try something else. Maybe angry? Why is it that the sky is blue and the grass is green? Yet no one seems to care about the real issues at hand. Stop being distracted by these trivial facts. We're living in a world where nature flaunts its colors while we ignore the bigger problem. Now you see the angry tone, and it well, it kind of makes it funny too. So the point being that all of these tasks earlier would have been quite hard for us to do with the traditional machine learning text mining algorithms, but with these new methods of app development, life has become easier and we can think a lot more innovative. Uh, Tools and for industry and also for you know humans to come up with rich language structures and rich apps. So that's it from me. I guess you enjoyed the session and you saw what ChatGPT API can do and some fun stuff also. If you have any questions.
Yes, I enjoyed the session. I'm sure everyone else did. Thank you so much. Do we have any questions? Let's see. Does anyone have any questions?
I do have a question. Thanks for the presentation. It was really interesting, actually. As you were saying that people are shocked that the technology was developed ages ago. I was just as shocked. Um, so like what you were showing, just in the last minutes there of the different models, like is the different models are different because they have different architectures, or they are actually trained on different data, or what kind of what makes them different in a sense?
They are trained on different data, I would say, but the problem with these companies, they don't tell you about the data, right?
Mm.
And that's a huge ethical AI and responsible AI. People are really mad about it that they should, and regulation is coming into place, and that's why some of the new models you would find them in US, but I think Google's Gemini and some other models were released in US, but EU is still worried about the training data and the companies are not disclosing it fully. But I would say, yeah, the training data would be different for these models.
So
However, yeah,
basically when you select a model, you actually don't know what it's been trained on. Like,
not the
or
training,
there's
not
no description at all of like what
nope,
that model is.
no,
Wow,
no.
that's
No.
impressive.
It's a huge issue, right? From a ethic, from a also regulatory point of view,
Yeah.
you should know about it.
Yeah, because like basically you're gonna see what it was trained on. So if you don't know what it was trained on, like how can you just trust what kind of the output is from there? But yeah, that's really interesting. Thanks.
Mhm.
Thank you.
But the parameter
Yeah.
information and how they trained it, all that about the architecture, they make it publicly available if you read their manuals, but not the
Mhm.
training data.
Okay. Yeah, well, at least that much, you know. Yeah.
Yeah.
Well, I
Uh,
have a question as well.
yeah, sure, sure.
You kind of spoke of using these models for using these models for application development and then comparing it to our traditional, machine learning, supervised learning methods, right? With supervised learning, you can easily evaluate. You can tell to like a very precise you can very precisely tell, how well the model is doing because, of course, you have your target already defined and you can kind of compare its outputs to that. So for these models, how do we evaluate them? what are some of the considerations that we should kind of take into account when using them for application development? Yeah, that's my question.
That's a very good question, actually. So it would depend on the task itself. A lot of people are doing let's say, hate speech classification, let's say sentiment analysis. They've been replaced by the traditional, let's say, logistic regression or support vector machine or transformer, with ChatGPT API being incorporated, and passing some of the inputs to ChatGPT and asking it to label. So if you have the ground truth for that task, you can evaluate. But if you're proposing a new task around ChatGPT, like this journalist assisting journalists with different tones, this kind of task is new. So here you might have to rely on user studies, because it's now the fascinating thing is a lot of people are coming up with new tasks also. And that's where the power lies. And that's where people think that a lot of innovation is going to come out, which is kind of slow, but also happening to a large extent also, like the way Grammarly brought in, I don't know if you guys use Grammarly, but if you are someone who needs to write papers and stuff, right now Grammarly has become so powerful that it can rephrase entire paragraphs of yours, which was earlier not possible. It would just correct spellings or make some small grammar suggestions. But now with this innovation, it's making something, sometimes it messes up too. It completely moves you off to another trajectory, but most times it's giving good suggestions. So these new kind of tasks, yeah, they're hard to evaluate. You would have to rely on user studies. But if you're doing a task with ChatGPT for which the ground truth already exists, let's say hate speech classification, let's say sentiment analysis, then it's the whole traditional way of evaluation.
Okay, thank you so much. Does anyone else have any questions?
Sorry, just to follow up with what you were just saying. So are you saying that Grammarly is using kind of ChatGPT interface as well, or just that they've gotten very good as well?
They are using some other model, but they are using generative AI too.
Oh,
I don't
okay.
think they're using ChatGPT. They are using their own model,
Mm-hmm.
but a lot of companies are now using these models,
Yeah,
LLMs.
cool. Thanks.
Yeah, you're welcome.
Okay, I guess with that we can call it an evening. Thank you all so much for joining, and thank you, Adriman, for sharing your expertise with us. It was very interesting. You broke it down, made it very easy for us to understand these technical concepts, right? So thank you so much for your time. I'm just going to share very quickly before we go in the chat the feedback form for everyone who's attended. Please just take a few minutes to fill it out. Let us know what you thought about the session. Yeah, that is it.
And if once the video is available, you will share with me, right? Because my students will also find it helpful.
Oh, yeah. Yes, we will. We'll share it. Abby?
Yeah, so we will put it up on so the recording will be up on our YouTube channel, and yeah, we'll send it on to you as well. The code, not quite sure. If you have a link where you already have the notebooks up, then we can just put it in together with the YouTube, or we
I can
could.
upload the code on my GitHub. Yeah, that's
Perfect. Yeah, that'd be great. And then we'd just link that in there. That would be perfect.
okay.
Thank you.
Thank you. Bye-bye.
Thanks. Bye.
Thank you.
Bye.
Bye. Have a good evening, everyone.
Good evening.
Bye.
So much.